What is expected value? It is the weighted average of all possible outcomes of an event. As you can see right here, that's the definition. But what does that mean in practice? Well, we'll look at that very soon, but let's look at the formula for a second. The formula is you summation sign of outcome times the probability of the outcome. That will give us the weighted average of all possible outcomes. And this formula is valid for discrete distributions. Discrete distributions are ones who have finite outcomes possible. A continuous distribution is one which has infinite outcomes possible. For example, if I were to choose a number between 1 and 2, and each number had equal probability of coming in, so I could choose 1.0001, 1.0005, anything. There are infinite numbers between 1 and 2, so that would be a continuous distribution. This is a discrete distribution where there are finite outcomes. So let's say a shoe size. If I ask you what your shoe size is, it could be from 1 to 13 or 14, maybe a little bit upwards. But there are only countable outcomes. There are no outcomes like my shoe size is 5.067. That doesn't happen, right? Only few countable options. So those are discrete distributions. Now, if I ask you what is the EV or expected value of a dice roll, and I'm going to say that there are 6 possible outcomes for a dice, 1, 2, 3, 4, 5, 6, a fair 6-sided dice. And this is the table for probability. So each outcome is equally likely. So each outcome has a 1/6 chance of coming in, right? So these are your outcomes. There are the probabilities besides them. So using the formula that we have above, E of x equals summation of x times probability of x, we see that expected value of a dice roll is actually 3.5. That is the weighted average, right? Each outcome is equally likely, so you just sum the outcomes and find their average. In this case, it's pretty easy because there are only 6 outcomes and each of them has equal probability. So the average expected value of a dice roll is 3.5. But what does that mean in practice? How can you get 3.5 on a dice roll? That's not possible, right? It's not. But what we are saying is, if we were to roll a dice a large number of times, let's say 100 times, I would say that if I sum all the outcomes that I got over 100 dice rolls, so let's say I get 1 on the first roll, I get 5 on the second roll, 3 on the third roll, I sum all of them up to 100 because I rolled the dice 100 times. I take their average and it should be very close to 3.5. That's what we are trying to say. This is what expected value means. Over a large number of rolls, the average would be 3.5. Now, this is the second example. Find EV of the following random variable. Random variable just has different outcomes possible. Don't pay too much attention to that, but just focus on the EV for now. So the possible outcomes are 2, 1, 0, and -1, and they are the probabilities associated with them. You can think of it as a 4-sided dice, but which is not fair. So because each outcome has a different possibility, you can think of this like rolling a 4-sided dice, but it's an unfair dice. What are the outcomes? 2, 1, as you can see, 2, 1, 0, -1. These are the probabilities associated with them. So what is the expected value? Again, we use the same formula, summation of x times probability of x, and we get that the weighted average is 2 times 0.2. That's its probability. And once we just add them, we get our expected value of 0.6. So what that means is, if I were to conduct a large number of rolls or trials of this biased 4-sided dice, on an average, the value of each roll would be 0.6. So I can sum my 100 outcomes, and then I can divide them by 100. I'll get something very close to 0.6. That's what expected value means. Hopefully you understood it. Let me know how you found the video, and see you in the next one.